As I mentioned, we're here really to talk about Dorado, our native all-flash array product. And so I'm going to do a high-level overview. I'm really going to focus on the software and the enterprise-class features. The real interesting conversation comes next when Chun's going to get into deep into the architecture on how we achieve our performance, how we do things at the architectural level. All right, so the first thing I want to do is convey that Huawei's been in the storage, in the flash business for quite some time now. As I mentioned earlier, and you actually saw, we develop our own SSD chips and our own SSDs. So that started back in 2005 with our first R&D investment in SSD technology. And we released our first SATA SSD in 2008. We are now on generation 5 of our SSDs. And over the years, we've released previous versions of Dorado. So starting in 2011 is when we released our first all-flash array. We refreshed it in 2012, again in 16, and in 2017 we released the Dorado with an NVMe backend.
You guys sell your SSDs commercially or to other storage vendors, or do you use them exclusively in your products?
I think we use them exclusively, yeah. And then, you know, as I mentioned, as our three pillars, all flash. Flash is a huge focus for us. So, of course, we are continuing to develop the Dorado platform. And not just flash, but solid state storage. All right, so from that 13 years of R&D innovation comes Dorado, which is really a combination of hardware and software. So we do some interesting things around hardware, as we've said multiple times. Our own SSDs, our own controller chips. We also develop the chips in our storage controller. So we have the chip in the SSD that we design, and the controller chips in the actual storage controller that we design. And then we do things around, you know, heat dispersion to make the SSDs last longer. We have a very high mean time between failure. I think it's 3 million hours or something like that. So very highly reliable media. Another hardware efficiency is we have smart I/O modules in the controllers that can be fiber channel or Ethernet, and that's software controllable. So if you want fiber channel, you just turn on fiber channel. If you want Ethernet, you just turn on Ethernet through the software. And then, you know, combined with our software innovation, optimized cache algorithms, good stuff that Chun will talk about later. Enterprise class feature sets like active-active replication, triple parity, RAID protection, and then of course the high efficiency stuff that you would expect in an all-flash array. So the three products right now, the Dorado 5000, which is our NVMe backend, but we also offer the 5000 in a SAS backend. Which, you know, I've got a spec sheet next so you can see the scale. Next is our Dorado 6000. And I've got the Dorado 18000 up here because one of our senior vice presidents announced it at Mobile World Congress a couple of weeks ago. It's not shipping yet, so I don't have any more detail in this deck about it. But since you might have heard about it, and I just wanted to acknowledge it in here, that we will be shortly have the Dorado 18000. That is massive scalability of 2400 SSDs. In a total racks enclosure, or 2400 in what size of? Oh, 16 controllers.
Like how many
U in a?
U, yeah.
Well, the controller is 6U, and the drive trays are 2, and they hold 25 drives each.
Oh, okay.
Okay. Yeah, and so when the scale out, it'll scale out to 16 controllers. And then up to 2400 drives spread out behind those 16 controllers. I think it's like 300 drives per pair. So just briefly on the spec sheet right now, what we support on the 5000 and the 6000. So we call our controller pairs engines. So the Dorado 5000 will scale to 2 engines or 4 controllers, and the 6000 scales to 4 engines or 8 controllers.
Is it scale out in terms of the management, or is it scale out in terms of like all my data is written across all of my SSDs behind every single controller?
Yes, the second.
the
Yeah,
second,
scale out, not just management. It's not a federation. It's actually scale out. Your data is
Active, active, or active, passive?
Active, active, or active passive controllers.
Yeah.
I believe they're active passive controllers today. Yeah, host port scalability. We support fiber channel SCSI and InfiniBand. Right now, the scale, so the PCIe, the NVMe drives, 50, 25 per. So you can't today put drive trays off of the NVMe version today. The 5000 SAS version will scale to 200 drives, and the 6000 will scale to 1200 today. And, 4 controllers, 4 engines, 8 controllers. And they all share common software, and that's what I'm going to focus on next. The enterprise.
Prefixes.
What's that?
At least prefixes, because all the things on top are smart, hyper, and
Oh, yes, I've got a slide. I'll
So do your engines add additional, they're adding additional memory and compute, but they're also adding additional fiber channel storage interfaces?
Yes. Yeah, and that's how we get to the high density port counts. Okay, so these are
And you said you could scale out to how many nodes?
16.
In a
So-
SAN configuration?
yeah, the 18,000 will scale to 16 controllers or 8 engines.
So 16 controllers or 8
Engines,
And,
yeah.
and what about the 5,000?
2 engines or 4 controllers today. Yeah.
16 controllers in an active passive would be 8 and 8, like 8 active, 8 passive, or one
It's all,
active,
it's active,
15
active,
passive?
right?
Can I comment on something?
Please.
So we are actually active front end. I think rubber means active passive because every LAN has an owner for a particular controller, but
Yeah.
every controller can accept I/O.
Oh,
So
yeah.
when I/O comes into a controller, sometimes if it's not the host controller, it's going to be forwarded.
Trespass in other
Yeah.
Yeah, I'm-
But we are active in the sense
Okay.
that every node can accept I/O.
It's active
Yeah,
passive
yeah.
at the LUN level.
yes.
Okay.
So we don't have controllers that are not doing anything, that are just passing data through.
Got it.
Yeah. Yeah, so
And with
all
the-
of your resources are working for you at the controller level.
And with the 24 NVMe SSDs, do you have like a PCI switch or something like that in there, or how does that work?
I believe we do. There's a PCIe switch in the chassis. We have PCIe switch. Yeah, because we have the 2 controllers that share the PCIe, and it's 25.
Is it 25?
Yeah.
Is it load balancing across those controllers? Your LUN gets assigned to a controller. Is it staying there, or is it just like when the LUN is created, it gets sort of identified with that controller until it's manually moved somewhere else?
It's actually can be migrated.
But your controllers aren't making that determination to across the. You've had 8 controllers in or 8. What'd you call? I'm sorry.
Just call it
engines.
controller is fine.
In a
Okay.
16 controller configuration.
Okay, so once your LUN is created, it's on controller 1. It stays there unless you go and move it to controller 2. So it's not balancing that
You're
out.
talking about load balancing, like automatic load balancing?
Yeah.
I'm not so sure. I believe we at least did some of that, but I'm not sure it's default. That I can find out.
So as a general default, it's not productized. We have a layer on the top of it as part of analytics and load balancing and orchestration. We're looking into that one right now. But in the package, in the product itself, you will customize it with certain LUNs associated with certain active nodes. and then go from there. And then the administrator has the ability to reassess and move the LUNs across if necessary. But it's not automated the way you would think analytics would automate it automatically, so to speak. There's some intervention required.
So do you have like a dashboard that'll kind of show like controller utilization?
Yes.
And okay.
Yes, that's exactly right. Yeah.
Yeah, and you might get to see that. I think you get to see that in the demo today. Okay, so I'm going to go into a little bit of detail on most of these software features, but just at a high level because we have the Smart series and the Hyper series. So Smart is our kind of our efficiency. So thin provisioning, quality of service, heterogeneous storage virtualization, which you don't often find in a Flash native storage platform, smart data migration, which works
When you
with
say smart virtualization, you're talking about external storage that can be
Correct.
controlled by the Dorado controllers, let's say.
Yeah, so you can virtualize third-party and Huawei storage behind a Dorado
So
controller.
external storage and internal storage.
Yes,
Yeah.
yes.
So what are the brands that are supported by the smart virtualization?
A lot, just off the top of my head, HP, EMC, HDS, but it's I don't have a slide on all of them,
Okay.
but it's a long list because it's the same list for our OceanStor product that we've been building up support for many years.
Okay, sure.
But I can get the list of
It would be nice.
of product. Smart data migration that works in conjunction with the virtualization to non-disruptively move data from an external virtualized storage platform onto the Dorado platform because you might not want to keep it there. If virtualized, you might use it to just move data to the new platform. Deduplication and compression, I've got a slide on that. Of course, inline.
And it's all software based?
Yes, this is all software. Deduplication and compression.
Yes.
Yeah, we actually have a slide on that in the deep dive. Snapshots and clones. VVol support, replication, both synchronous and asynchronous with 3DC support. Hypermetro for stretch clustering. And we just recently implemented an internal key manager for customers that don't want to have to buy a KeyMIP server and do external key management, but we do support that as well. So this helps reduce costs for companies that just want key management for the platform.
About Hypermetro, what is the requirements to realize that in terms of networking?
We support Fiber Channel and Ethernet.
Okay, only fiber channel supported.
And Ethernet.
Okay,
Yeah.
and in terms of latency?
Latency.
Latency, yeah.
Actually, we have some patented technology that helps reduce latency and round trip between the controllers. Actually, I've got a slide on Hypermetro, but if I recall off the top of my head, we've measured 200,000 IOPS at, I think it's 1 millisecond latency.
Okay.
But I've got a slide on that. And then actually, I think Chun has a much more detailed slide. Okay, so now I'm just going to touch at a high level on features, so a little bit more detail. And as I mentioned, Chung has the architectural level view with a lot more information. So HyperSnap, our snapshot technology, as you would expect in an all-flash array, instant, writable snapshots, cascading, so snap-on-snap, and cross-level rollback. So you can restore a snap-on-snap back to the primary.
Can you do VMware like aware snapshots on like a runner volume basis?
We will support VVol soon, but we can't on a LUN with multiple VMDKs, for example. We can't with HyperSnap. We can't pick just the blocks associated with VMDK and snap it.
So you have no vCenter integration that would snapshot your virtual machines and then snapshot your data store and then release the VMware snapshots?
Not-
I think what you're saying is because it's a LUN, you snap the whole LUN. You can't snap, unlike
Yeah.
Evol's case where you can snap at VMDK level.
Right, but I mean, if you wanted to snapshot an entire data store that had all of these virtual machines in there, like that's what I'm getting at is.
Right.
Yeah, we have a VASA VAI integration, vCenter support. So I'm not sure the specific use case, but I think we do. Again, so if somebody's taking notes, I can get that information. But we have pretty good VMware integration. So I'll double check.
I mean, if you're using the vSphere API for backups, that'll naturally snap it anywhere at the VM level. So, yeah.
Yeah, but we do LUN level snapshots. So if there's multiple, we have to take the whole thing.
Right.
And then we also still support cloning. So we actually have customers that even on our flash array with writable snapshots, they still like clones. So we've left that feature in there. SmartDedupe SmartCompression. Again, as I mentioned, this is global deduplication, inline, and inline compression. However, it's flexible, so if you know you have a workload that doesn't dedupe well or doesn't compress well, you can actually turn either on or off if you want. However, all of our marketing numbers, everything we publish for marketing, our marketing performance claims, can somebody help with that? But all of our marketing claims are with all of the features enabled. So it's not like we're saying we can do 4 million IOPS at 500 microseconds of latency until you start using the array, until you start turning things on. So, but you can turn them off selectively, both dedupe and compression.
Is it only inline, or can it be run post-process after the fact? So if I decided to turn on dedupe and compression on an existing LUNer volume, will it go and dedupe and compress it afterwards?
No.
Okay.
So it needs to be done, turned on. The decision needs to be made when you create the LUN.
And when you say inline, it's really from the cache to the back end storage or something like that. It's not, between the front end and the cache. You do cache, right?
Yes.
Yeah.
Yes. And actually, there's a detailed slide on this.
Naturally.
Deep dive. Yeah.
Yeah,
I'm frosting. The really good stuff is next. And we offer a 3-to-1 guarantee.
One other question that 500 microsecond response time, 800,000 IOP SPC1 result that you guys have published was with inline data deduplication and compression on?
Mm-hmm. Yeah, and actually we've got quite a bit more performance data to share in the next presentation. Yeah, and that's actually one of the things that I really want to, which maybe not be doing the best job of communicating here is our performance with the enterprise class features enabled. And that's what we think, one of the things that helps set us apart in the industry. Because I know a lot of the native built from scratch all flash arrays are starting to get enterprise class features. They didn't start with them. It started with performance, all about performance. So all flash array startups are starting to get enterprise class features, but we were able to deliver enterprise class features on a truly native built for flash platform without sacrificing the performance. Now, that doesn't mean that if we turn some of these features off, our performance actually gets better, but we don't market that high number. We market the numbers and we do our SPC tests with the enterprise class features enabled. Yeah, so RPO 0, RTO near 0, gateway free, so we don't need to have an external gateway to make this happen. It's native in the array. And as I mentioned, so we have tested, and you'll see, I think there's a slide on this in the deep dive, greater than 200,000 IOPS at a millisecond latency. And there's some patented technology that we have that helps reduce round trip communication between the arrays that is required to set up the writes. And we also have a very quick recovery. So we've measured return to stable state after a failure to within 3 seconds. And this is evolvable. So you can start, the customer can start with only local data protection snapshots or clones. And then they can add active replication without interruption to service. They can add then 3DC to that, their protection scheme without interruption to service. And we do fan in and fan out of up to 64:1. And another important thing, I touched on this when I was talking about the portfolio, about the feature compatibility. So we also allow the customer, we have the capability to allow the customer to do replication from an all-flash array, so a Dorado platform, to an OceanStor platform. So if they don't need the performance on the remote site, they can actually purchase a lower cost hybrid array, for example, to fan in a number of Dorado platforms if they want, to help reduce the cost of their data protection scheme. And that's all native, of course, still no gateways required. Smart virtualization, as I mentioned, I'll get a list of the supported
models, right?
Yeah, models. Yeah, we have it's a comprehensive list. But it's, as you would expect, it's storage virtualization behind the Dorado platform. So all I/O goes through the Dorado to the back to the storage that's being virtualized. And smart quality of service. So we have priority control, a priority policy and a flow control policy. And just, a pretty graph so you can get an idea of what it looks like. So priority policy, we can break these into kind of internal I/O queues. So we can split it up based on, in this example, we have mission critical or key applications, important applications, and there's ordinary applications. And this is what it looks like before. And then when we enable priority control, you can see a clear delineation between the 3 queues. So we actually have the separation now. And then we also offer flow control, which is a little simpler. So flow control is basically the ability to set up an IOPS or a bandwidth limit for ordinary applications, for example. So in this chart down here, what we have is we have ordinary applications in green and our high priority applications in red. And they're going along and everything's okay. But then there's a spike in activity in the ordinary applications, which causes a problem in our high priority applications. By enabling flow control, we can set the upper limit of the ordinary applications bucket, if you will, and that controls the resources that they can utilize, which prevents that noisy neighbor, that drop in service for our mission critical or high priority applications.
Is that just done on a per LUN basis?
I believe it is per LUN. Our QoS is on a per LUN basis. I believe it's done when the LUN is created, but it can be changed. Okay, and so kind of bringing it back to the performance, and this is the last couple slides. So our SPC1 benchmark was 1 million IOPS at under 500 microseconds, and you can see as it ramped up to 1 million, we're still under the 500 microsecond level. And the configuration was a Dorado 6000 with 4 controllers and 900 gig SSDs. So that's the SAS version of the media. And I mentioned earlier that we scale, the 18,000 will scale up, and all of the 6,000 could scale up to 16 control. Actually, the 5,000 could too. And it's tested, we've tested it at 16. We just aren't GAing that big of a system. But the 18,000 will scale up to 16, and we have tested performance, and it scales near linearly. So we actually measure 4 million IOPS today with the current processors, which we haven't revved yet, to 4 million IOPS at I think it's under a millisecond of latency. And we do that through end-to-end flash optimization. So as we touched on, we designed the chips and the SSDs. We designed the chips and the controllers. And then we have our flash link technology that links the two, that brings the two together. So the SSDs are cooperating very closely with the storage controllers, which allows us to achieve that performance with our enterprise class features enabled. And as I mentioned, Chun has some really good performance slides that actually show performance measurements with dedupe, with compression, and even active-active replication enabled. And then we have a demo that we can show, that will show as well. And active-active hypermetro is part of the demo.
Your controllers, do you have, I know you passed around chips. They're running their own custom processors for, or are they
not
Intel
processors right now, but they have these, the storage controller ASICs in them.
Okay.
Yeah. And, but we do also have, so in our OceanStor model lineup, we have a 2000 series, a 2200 series down at the low end, that the Robo version, that's like 3 clicks to configure under a minute. It actually, we have versions that use our ARM processor to help performance and keep costs very low. Okay. Oh, and one shameless plug. We are starting to get recognition on Dorado. So Interop, last year, 2007, we won the grand prize for Best in Show for our Dorado platform. And this was in Tokyo. And we did ask ESG to come in and validate our claims, and they did. So we can actually share this document. We also we have our OceanStor V3 product was a DCGI Best Buy last year as well. So